So what kind of stuff's likely to be on it? Well, we've spent a lot of time talking about lists. So, lists, how to declare one, how to print the elements in it, how to append an element, how to insert an element. We've done all that a couple of times. Hopefully that doesn't look alien.
Are you recording?
Yes, I am. Also, slicing. Python's the only language that calls it a slice, I believe. That's when you use, that kind of nomenclature. So if you have a list like this, B is equal to R, comma, O, comma, S, comma, E. And you want to make another string that just has these two elements. Not a string, this is a list, sorry. And you want to make another list that has just those two elements. That's element 1. So, and that's element 2. So we could do this. C is equal to B, but we want a slice of it starting at element 1 and going up 2, but not including 3. So that's 0, 1, 2, 3, up to but not including, so that would build us a list that was equal to OS. If you leave off a number in front of the colon, it means all the way to the beginning. Like, big deal, you saved yourself 1 character typing by not putting 0 there, but whatever. And then if you put a number so this would do starting at 0 up to but not including 3. So which elements would that be? Right there. Well, that's 0, starting at 0, up to but not including 3. 0, 1, and 2. So that would equal that. How about this one? This one means starting at 2 and going to the end. So what does it equal in this case? Well, what's element number 2? It's the S. And of course, if you do not put a colon in it, your slice consists of a single one. So if you print B sub 1 or B subdo, what's that going to print? That's going to print the S. And we know what the negative 1 means. It means go to the end of the list. So that would be the E. Negative 2 would be the S, negative 3 would be the O, and negative 4 would be the R. So, printing that list, I think I would use a for loop. For, now somebody give me a variable name. Did I hear X? I don't know. X in B. Print X. That would print out R on one line, O on the next line, S on the next line, and E on the next line. If you wanted to use a while loop for some reason, you were stubborn, rather than a nice, easy to use for loop, you would do it like this. First you have to declare your counter, except you don't use the word int. This isn't Java or C. And then while I is less than the length of the list, print B at position I. Then you have to increase I. There you go. I plus equals 1. Now, obviously, that's simpler to type. Syntax is just way easier. All right, then there are built-in functions. There's sum. There's min. There's max. I'm kind of spacing out on the others. There's hundreds of them. So if you wanted to use sum, say you had a list that, I think I'm actually going to pop open idle now. That's not idle. So I'm going to declare list, which is going to be J, and it's going to be Jenny's phone numbers, 8675309. And I want to find out what the sum of all those are. Print sum of J. It added all those numbers up. We could have written a for loop or a while loop to do it, but we have the sum function. We may as well use it. Print the maximum number in that series. Well, what's the maximum number going to be? It's that 9. Not because it's at the end of the list, but it's the largest of the values. Oh, I remember the other ones. We need to be able to search the list and find a position in it. But if I can't remember how to do that, I'm not going to ask you. Okay. Min works the same way. Pardon me?
You did some good.
Yeah, I did. Print the minimum. There we go. And the minimum of that list is a 0. All right. Sorry. Find or search list Python and return index. It's dot index. Okay. Say I want to find out which is the index value of that 7. And I actually don't think I'm going to ask this. But j dot index of 7. I think I should have used a capital O. J dot index of 7. And that didn't work either. Okay. I'm certainly not asking you. Oh, it's just index, not index of. Sorry. I slipped into Java there again. Alrighty, one more time. J dot index, and I want to find 7. Well, 7 was at element number 2. And it doesn't matter whether it's, a list of strings, like a list of movies or names or a list of numbers or whatever. It would work the same way. B for books, or no, C for colors. Colors are easier for me to create off the top of my head. Red, orange, blue, black. Now I want to find out the index number of that one. I want to search it. C dot index and look for the string black. 3. It searched the array. So I'll put this in here, but I'm not going to ask you to do it. I just want you to see it again. Alright. That's probably enough about lists. How about that code that we were doing where we were searching a password for a specific value? There were a couple of different things we were doing there, but we wanted to see if something was an alpha, for example. So what we did to check to see if something was an alpha, say we had a character or a string that just had the letter A in it. Then you would do ch.isAlpha. No, you wouldn't. Oh, there we did it. It was not capitalized. Okay. So, once you have a character or a string, and you want to see if it's composed of all alphabet characters, you do isAlpha, like that. Now, that is the letter A, so it is an alpha. Is it an alpha num? Yes, of course it is, because we've already figured out it's a alpha, so we also know it's a numeric value. Oh, you. Alnum. Excuse me. Trust me, the exam is going to be easier because it's just going to be matching in this point. Okay, so ch.alnum is going to return true on that. Oh, isAlnum? Yeah, ch.isAlnum. And because the letter A, or if it was an entire string, that'd be okay, is composed of all alphanumeric characters. So if we had this, S is equal to A, 1, 2, 3, B, and then I do S dot is alpha, is that composed purely of letters? No, so this is going to actually be false. How about is alpha num? Is that going to be true? Is it composed entirely of alpha or numeric characters? What's it got that's not an alpha or numeric? You don't count the strings, the quotes on the side. So it is all alphanumeric characters because it's got alphabet characters, A and B, and it's got numeric characters, 1, 2, 3. So that's going to be true. Oh, I did it again. S dot is alnum. Alrighty, there we go. What about is digit? Well, that is not composed only of digits. So that's going to be false. How about uppercase? Is it all uppercase? Well, let's give a new name. S is equal to Jeff. Is upper? It's true because it's all uppercase. Is lower? That's going to be false because it's... And so what we did in our password program is we pulled out each character of the password using a slice, and then we ran it through a whole bunch of if statements. If it's a digit, we increase the number of digits. If it was an uppercase, we increase the number of uppers. And I have forgotten the one that would tell us whether it was a special symbol or not. Let's go take a peek at the assignment. Oh, we just checked to see if alnum is equal to false. Because if alnum is equal to false, then we know it's got special characters in it. So right now the string Jeff doesn't have any special characters in it. It doesn't have any symbols. So if I do s dot is alnum but I stick the word not in front of it, or I put equals equals false, it's going to say false because there's no special symbols in it. But what if it did have a special symbol in it? Jeff, like that, whatever that means. Okay, now when I do not s dot is alnum, it's going to say true because it's got a special character in it. So these are almost self-explanatory when you're seeing them. Is digit, is alnum, not is alnum, is alpha, I should not have a space there, I think that was about it. Oh, and is a lower and is upper. So the following string functions test the string. So what does is digit check for? Is the string all numbers? What does is alnum? Is the string all numbers or letters? What about not is alnum? Is this, does the string have special characters in it? Does the string have symbols? Is alpha, is the string all letters? Is lower, is the string all lowercase? And is upper, is the string all uppercase? So we've talked about defining functions. How do you define a function? What's the key word? Yep, def. So let's write a function that prints the word hello. That'll be our first test. Then write a function that accepts a parameter x and prints it. Then write a function that accepts two parameters, x and y, and returns their sum, their total. I didn't give names, and if I was going to give this to you on the exam, I would give you names. So write a function. The function name is going to be say hi, or say hello. That's the name of that function. This one is going to be called print x. And the next one is going to be add to. Okay, so what would this one look like? This is easiest of all. Doesn't accept any parameters at all, doesn't have a return statement. Yeah, but what's the first line? It's going to be def, say hello. It still has to have parentheses, even though it doesn't take any parameters. Then you have to put a colon, and then print hello. Write a function that accepts a parameter. When I say takes a parameter, accepts a parameter, has a parameter, that just means there's going to be something between the parentheses. So, how do I start this one off? Yep. Define print x, and then I need parentheses, but I need something between it. There we go. Pardon me? Now this one just takes a parameter, so we don't need any input statements. Yeah, just print x. And if we wanted to put return functions on returns, we could. It would just be return without a word. So that's okay. I could do this. Return nothing. I could do the same thing here. Return nothing. That's optional unless it's actually supposed to return a value. Okay. It's mandatory if it's going to return a value. If you're flowcharting a function, go ahead and stick that return statement down in the bottom oval. Define, this one's called add2, and it accepts two parameters, x, comma, y. And you could just do it as a return statement, or you could add them up and then return that. A is equal to x plus y, return A, like that. If you're going to flowchart one of these guys, what do? Let's write a itty-bitty little program that uses one of these. We're going to use this add2 function in a program. I'm not going to pseudocode it first, I'm just going to code it. But I may as well actually put it into idle so I can test it first. You generally define your functions before you use them, so there we go. What is our code going to do? Ask for two numbers, then use add2 function to add them and to print them out, and then print them out. Okay, now we are going to do some input. That's what ask for two numbers means. We could be more specific. We could say ask for two numbers x and y. I wasn't specific, so you could call them whatever you wanted to. Fred and Barney, Bugs and Daffy, x and y. We'll go for x and y. Then we have a decision to make. Are these supposed to be ints or are these supposed to be floats? So I probably should have specified that in my requirements. Why do we need that? Just because we need to know what to convert it to before we pass it to the add function. All right, I'm going to just pause here for a minute and let y'all go ahead and write the code that does this, because I bet you can. And if you can't, it's okay, but you know how to use input statements, you know how to use the float keyword, you know how to call a function, and you know how to print it out. All right, I'm basing how much time to give you all based on the clicking of fingers, so don't be writing email. Alrighty, so asking for two numbers, floats. Remember that you can always do things in as few statements or as many statements as you want. What I've been showing you is to use a print statement followed by an input statement followed by a conversion. That would look something like this. Print, give me a number. X is equal to input. Then I want to convert it. How do I convert that? X is equal to float x. Then I would repeat those three lines. Give me another number. And I'm just being silly with the gimme business. Of course, that's not required in the exam. Okay. X is equal to, Y is equal to input. Y is equal to float. Y. Now we have two values.
If you hit return, like if you wanted it to return, like I said A equal to X plus Y, and I put return A, but it didn't return anything.
Well, have you called it yet? I'd have to come look at your code. Let me come peek at it. Okay, you got a whole bunch of stuff there. Take all of this stuff from print down to y is equal to float y. Cut that and put it down here. So we'll get there because this stuff here is not part of the add function. If I'd said modify the add function to add input and things like that, yeah, we would put that up there. So anyways, now we are going to call add2 using x and y. But for us to be able to print it out, we probably ought to store the result. R for result, I don't know. R is equal to add2, and then pass those numbers in. And then print R. Now when I say print them out, that's kind of implying I was printing a whole bunch of stuff out, so maybe I might print out X, comma, Y, comma, R, just so I can see all those. Or maybe I might want the words, the sum is, something like that. But there we go. That is our completed code, and it might even run. Let's find out. I'm going to call this one add2. Run it. Give me a number. 10. There we go. One of the very, very, very first viruses, back before the internet really, was called the Cookie Monster. And it would interrupt your program to say, "Give me cookie." And you better have typed cookie fast, or else the next thing it was going to say is, "Give me cookie or I'll gun you." And if you still didn't type cookie, then it would start printing bang, 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 bang over and over until you typed cookie. Okay, so people are pretty weird. Alrighty, so there we go. We have defined a function. We wrote some code that used it. I hope you could flowchart it. That'll be what we do next. Now before I just randomly start flowcharting and y'all robotically copy me, a function definition. How do you define a function? You still use two ovals to start and stop it, but what's in the top oval?
The name of the function.
Yeah, the name of the function and any parameters. And if you want to add the DEF keyword as well, that's cool. How about the last oval? What do you put in there instead of stop?
Return.
Yeah, the return A. If it doesn't return anything, it still returns something. It's returning nothing, so just put return. Even if the word return is not in the function, put one on your flowchart. It just doesn't have a value. Now when we call the function, what kind of symbol do we use?
It's a predefined.
Yeah, we call it the predefined process one. It's the rectangle with the bars. Hey, look at that. It's missing its F's and its P's and stuff. Anyways, okay. Print and input statements, what go in that kind of shape? What? That was not good English. Inputs and floats, inputs and prints go in what shape? Yeah. Yeah, tilted quadrilateral. How about something that's pure math, like a is equal to x plus y, or I is equal to 0? That's going to be in a regular rectangle process. This one doesn't have any ifs or whiles, so we're not going to need any decision blocks. All right, so crank lucid chart up. Work on flowcharting this. I'm going to give you a minute or two head start on me.
Return would be in the oval.
Yeah, you put return in the ovals. So you're going to actually have two columns. One is going to be the function. Oval at the top says add 2. The oval at the bottom says return A. And then you're going to have another one with a start and a stop. And which one you put to the right and which one you put to the left is your choice. I usually put the functions off to the right. Bless you. And when you're doing flow charting, you can kind of play fast and loose. These three things could probably be lowered down to be just a single input-output. You know, I would do it that way if I was drawing the flowchart first, perhaps. But in this case, I'm going to make a match pretty exactly. So I have a print statement.
I have a question.
Yes, sir.
I didn't define my function with a variable. I just said print and then I put the function name. How would I put that on a flowchart? Because for prints we use the parallelogram, but for functions we use the double lines.
Oh, you printed the result of the function? Yeah. Good question. I don't really think you could flowchart it like that.
Okay, so should I just make it a
Yeah, programming is more flexible than flowcharting, weirdly enough. It's kind of like to get that to work, we would need to embed a symbol within a symbol. And I can't really think how to do that. That's a really cool question, and I'm not sure how I would answer that except to say that you really ought to break it up. Okay, so print enter number or give me number or whatever. And then x is equal to input. Now what almost everybody wants to do is put the float statement in another tilted box just because we had two tilted in a row, but instead it's math, so we put it in a process block. Then I would need to repeat those three things for y. Although you don't have to. I'm going to squish everything close up together to try to get it all on one page. Alright, I'm at the point where I have x and y. I need to put a call to add to. That's where I'm going to use my predefined process call. R is equal to add to x comma y. Then I would print that out. And in my flowcharts that I was drawing before I did the code, I was leaving off the parentheses around the print statements. It's not right or wrong. Alright, now for the ultimate in cheats, I'm just going to draw a line from the start to the stop, and the reason I'm going to do this is simply because there's no loops or anything, so it's a straight shot, and it saves me the time of having to fill them all in. However, I don't want that line going in front of everything, so I'm going to right-click the line and do Arrange, Send to Back. Now the add to one is simple. It's only got 2 bits of data. What's the first function under the def add to? I shouldn't call it a function, but pardon me?
Rectangle is a plus x plus y.
Right, and that's going to be a math block. So a is equal to x plus y. And I already had my return a down here just to get psyched about it. So there we go. Okay, so that's my flowchart that matches the code line by line. When you're flowcharting, whoops, I meant to send that line to the back. When you're flowcharting before you have the code, or you're doing pseudocode, you don't have to be so precise. You could just say tilted rectangle, ask user for x, and then another tilted rectangle, ask user for y. Then these two things would probably look the same. So there would have only been one quadrilateral there, another quadrilateral there, and then an add to statement and then a print. That's how I would have done it if I was doing the flowchart first. Can you be more precise when you're doing the flowchart? Yeah, you can. But if you don't know the language that the user is doing, then you're going to way too much work. And what I mean by that is the way you get input from Java is completely different than the way you do it in Python, is completely different than the way you do it in C++. So by giving them all this Python here, you're just making their brains work harder, because a programmer knows how to get input in the language that they're already familiar with, and you don't need to tell them. So I could have made this, if I was flowcharting it first rather than from this source code, look like this. There would have just been one block that said ask for X or give me a number. Another block. And then the add to call. So ask user for X, ask user for Y.
What other language doesn't print, like display a message? What language doesn't use print?
Java uses println, or the whole word is Java, excuse me, yeah, dot, I totally spaced. System.out.println is how you do it in Java. And in C++, you do it like this. So this is Python, print A. Java is system.out.println, quote, or A like that. And C is really weird looking. That's how you do it in C++. Input is both similarly different. To get a number in Java, or excuse me, in Python, you do, like that. In Java, you have to have something called a scanner declared, and you have to decide what kind of data you're getting. You have to know whether you want a double, or a float, or an int, or a string. If you wanted an int, you would use next int. So that's the Java version. Except Java uses different comments. And then if you were going to use C++, you would do that. I forgot one more thing on this cout. You would need to print out end line, so it would go to the next line. So that's kind of why Python is cool. It's easier to do it than that or that. Here, in order to use this next int command, we would have had to have declared, we would have had to have added an import up at the top. We would have had to declare and create our scanner, and then and only then could we use it. So there would at least be 2 extra lines of code just to get ready to use this for Java. Same for C++. You would have to add an import. You would have to have probably a using statement. Several lines of code just to get to the point where you could do these. Whereas with Python, boom, it's one command. So Python is a good learning language, and it's not just for learning. A lot of pros use it for a lot of cool stuff. Data analysis at NASA, for example, they use Python nowadays. Because with the graphics libraries, you can draw things really quickly with it. Graph your output. Okay. Anyways, where was I going? Obviously, this is not going to be on the exam. Those things. Know how to flowchart a while loop as opposed to an if, as opposed to an if-else. We know that already, right? We don't have to do that again. If looks like this. You have 2 things that happen. Either it comes over here and does something, or it comes down here and it does nothing. And then you hook the lines back up. That's your if. Your if-else, everybody wants to put a symbol that means else, but there's no symbol that means else. You just put something on the no side. Yes, you do one thing. No, you come and do something else. Like that. That's an if-else. The while loop, it doesn't drop down like that. What does it do instead? If I was going to change this to be while, so instead of if condition and if condition, if I wanted to make a while condition, it goes back up like that. in which case you don't need this little circle at the end, really. The circle is just to give us a place, you know, to draw another line coming away from. All right, those are the three loops. We did a few variants, I think, like an if-else if or a nested if. What does a nested if look like? It's an if inside of an if. We have a big if, an outer if, and then inside there could be another if. And that one would jut off and do something over here, if that was true. Then they would loop back into their little circles, and then that would loop back to another circle, like that. That's your nested if. You can have nested while loops as well, or you can nest a while loop inside of an if, or nest an if instead of a while. You know, if this one said while, then the line would just come back up to there. If this one was while, then the line would come back up to there. If I was being careful, I would delete the text from these little circles. The only time you need letters in those circles is if you use them to jump from the bottom of a page back up to the top of a page. Okay, so this is our nested if. The other one was our if. This one was our if-else. This one was our while. And let's do a if-elif, which is the weirdest one, in my opinion. So the code we're going to do now will look something like this. If condition, elif condition, else. That's really what I want it to do. And it's going to have a process block between there, and it's going to have a process block between there, and then it's going to have one last process at the end. And I might call them process 1, process 2, and process 3. Okay. So how do I start the top if? The top if is easy. It's just one of those diamonds, right? If condition, then do process 1. Where it gets weird now is that when you're using elifs, it doesn't come back to this. This would not be right, having them both come together and do another one. That is not elif. Instead, I'm going to just leave that line off for now. And I could either put the word else, yeah, elif, there we go, condition, then I do the second process. And then lastly is my else. I could come and do a third process. All right, I need to grab this stuff so that I can manipulate it a little bit. What is wrong with this code as I've drawn it, besides the fact that that's a dead end and that's a dead end? I got a bunch of dead ends. So really, I'm just going to put a circle down here at the bottom and hook up a bunch of stuff. Like that. Like that. Each process block needs to go down to the final closing circle rather than going back to the if condition. Like that. So that's an if-elif. It's a little bit weird. It's ugly. And the reason why it's ugly is because programming was invented after flowcharting, and it was never really updated. So, there we go. If something, do something one. Elif, and you could even lose that word L. You could just make it if condition two. Actually, in strict old school flowcharting, you don't use the word if or while at all. You just do that. And then the programmer's just supposed to make it up. Oh, I know that that's an if because of one thing, and then nothing comes back to it. And oh, I know that this is an else if because. So anyways, I figure our flowcharts, we are in command of our own destinies. We can put these words there if we want. Alrighty, I hope that makes sense. Those are the important structures to know how to flowchart. Flowchart if, that's easy. If else, that's also pretty easy. While, that's pretty easy. And if, elif, else. The most tedious of them. Alright, gang. I think that's about enough to put on an exam. So, let's go ahead and make a Dropbox for anything you've typed today.